Hello and welcome to Calculus tutorial. We are again going to take a look at relative extrema and do two examples of how to find relative minimums and maximums. And what you do to find a relative min or max really depends on what you're given. You're still often going to use some sort of derivative test, but how you apply that depends on what you are given. So first we're going to take a look at what if you're given the equation and no graph. Alright, so here we have an equation y equals x squared over x plus 2, and we want the relative extrema. So minimums and maximums of this function. And so we're going to first by taking the derivative, y prime. We want the extrema of this function here, and so we need its derivative to figure that out. That's going to be a quick quotient rule, probably the easiest. So the derivative of the first times the second minus the derivative of the second times the first, all over the bottom squared. So let's see, what are we going to get on the top? 2x squared minus 4x minus x squared over x plus 2 squared. And this just becomes a simplifying a little bit. So I'm going to go kind of quick here. We will have x squared minus 4x over x plus 2 squared. Factor the top, so you get x times x minus 4 over x plus 2 squared. Alright, so what we need to do here is take that derivative and figure out what makes that equal to 0. It looks pretty complicated at first. You're not going to actually solve this equation. You just have to think about it intuitively. First off, the denominator is never going to make this fraction 0 because you can't divide by 0. So you don't actually have to think about the denominator. Just think about the numerator. What makes the numerator 0? Well, two numbers, x equals 0 or x equals 4. Now you do have to think about one more number. How do you make the denominator 0? Because remember, a critical point is any point where the derivative is 0 or undefined. And so if the denominator is 0, your derivative is undefined. So those are our three x's that we have to consider. Since we know those, we can now put them on a sign chart. So we're going to have 0, 4, and negative 2. So now we can do our sign chart for that. So let's see, at negative, if you plug in a number below negative 2, like negative 10, one nice thing, I'm going to plug it into the factored form here. That's the easiest version. I don't need to think about the denominator because that is squared, and that's always going to be positive. So just plug them into the numerator to get your sign. So we're going to have negative 10 times another negative number, so a negative times a negative will be positive. Then try a number in here, like negative 1. So negative times a negative is also going to be positive. On the other side of 0, we're going to do a number like 1. That will be a positive times a negative, which is negative. And on the other side of 4, like a 6, we are going to have positive, positive, so positive. So as we look at this, 0 looks like that will be a max. 4 will be a min. All right, and so that's how we can do that without a graph. Oh, let me talk about 2 here first, -2. So for -2, that is of course neither because it's going from positive to positive. But that one you also have to be somewhat suspicious about. Because the derivative was undefined, it's very possible that your original function is also undefined there. So you come back over here. Can you plug in -2 in for x? It's still undefined. So no matter what, this one would not exist. There's an asymptote there, or a hole, in this case an asymptote. So that would not be something that we want to consider, but you still need to put it into your sign chart so you can get the sign change, because there might have been a sign change there with that asymptote. And so you do need to put the undefined numbers on your sign chart. In this case, it turned out to be neither, so we got kind of lucky. That won't always happen. All right, so that's how you do it again if you have the equation and no graph. What if you are given a graph and no equation? All right, how does the process differ? Now, I'm not going to give you the graph that you probably want. So find the relative extrema for the function f of x. Now notice I'm asking for f, but what we are given is f prime. So I have a graph of f prime, no equation, and I want the minimums or maximums for the original f. Now this is actually easier for us because what's the first step? Take the derivative. Well, we have the derivative, so we don't need to take it by hand. So what are we looking for? Remember, if you have your function f and your derivative f prime, if you're looking for a minimum, that is where your derivative is going from negative to 0 to positive. So where is that happening on the graph of f prime over here? Well, here we're going negative, and then we're at 0, and now the graph is positive. And so we see that behavior in the graph. We know that at x equals 1, there must be a relative min. So I'm actually going to write out the whole thing with the justification. Must be a relative min because, so the first thing we looked at was f prime of 1 is equal to 0. That makes it a critical point. And the derivative, f prime of x, is changing from negative to positive. And actually, to make that even better, I won't say x equals -1. I will say f at -1. All right, my other one, hopefully you can pick out the other one's going to be right here. That is where the derivative is equal to 0 again. But here we're going from a positive value to a negative value. So f at 3, and because we're going from a positive to a negative, that will be a max. And I'm going to write almost the exact same sentence. A relative max because f prime at 3 is 0 and the function f prime is changing from this time positive to negative. Now there's one more that we should consider because this is a critical point. We said it right here. And this is a critical point. This one here and this one here. There is also a critical point right here because f prime at 2 does not exist. So that could also be a relative min or a relative max. Now again, we kind of look out here because it will be going from positive to positive. So there can't be a minimum or a maximum. It's neither. We don't quite have enough information either because the derivative is undefined, which means there's it's highly likely that the function will also be undefined. But it doesn't have to. I don't quite give you enough information on this problem with just the derivative. You would need to know a little bit more to say something of consequence about f at 2. But here we luck out again because we're going from positive to positive. It can't be a minimum or a maximum. But it would be something you'd have to consider. All right, so we've taken a look at 2 other examples about how to find relative extrema. Again, your procedure will be dictated by what information you're given. If you're just given the equation, you oftentimes have to take the derivative, set it equal to 0, and do your sign chart. But if you're given just the graph of the derivative, you don't have to take the derivative, you're already given it. So you have to sort of take stock of what you're given before you know what to do.